Welcome back to Code and Confidence. Today we're going to be going over a binary search algorithm. It's a cool, fun concept. I'll read the description and we'll get to coding. Given an array of integers nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, then return its index. Otherwise, return -1. You must write an algorithm with O of log n runtime complexity. So we're going to basically search through this array here and see if the target number, 9, is present, and if so, we're going to return its index. This logarithmic runtime is going to be faster than a standard array search, because you could just do this very easily. But this method is faster for computers to do. So we'll get right into it. First, we're going to define some variables here. We're going to let low and high equal, we're going to set this at 0, and then nums.length -1. Now we're going to run a while loop that goes over this array here. We're going to write while low is less than or equal to high. And now we need to define the midpoint, because the whole point of a binary search is that it's it only takes like half the time of a normal search. Not quite that, it fluctuates a little bit, but that's the idea. So we're going to find a midpoint. I'm going to create mid equals, and to find this midpoint, we're going to go math.floor. This is in case the data set is odd numbered. In this case it is, so in order to get an accurate result, we need to round it down. If it's even, it'll come out even, or round integer. If not, gotta use math.floor. So we're gonna do low plus high divided by 2. So that's gonna find the midpoint of the data set. And we're gonna say if nums at mid equals target, we're just going to return mid, and that's going to return the index of the target. And else, if say our midpoint nums at mid is less than target, we're going to want to make the low equal to mid plus 1. Otherwise, this will cover if mid is, or sorry, nums at mid is higher than the target. We're going to say high equals mid -1. So we're just adjusting the low and high points of the data set to get a more correct midpoint, and that will take care of everything. Now we just need to return -1. So let's run it. So we have console.log binary search with this data set and this target number. Oh, num is not defined. Where's that there? Oh, num.length. Silly me. Little errors. There we go. 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Perfect. And if we do a number that's not in there, it should give us -1. Perfect. So the reason that we need to do an ordered data set for a binary search is because of the nature of splitting everything in half and running numerically. It needs to be sorted. If you have an unordered data set and you still want to have a logarithmic time complexity, then you'll need to find a good sorting algorithm, like a merge sort or a quick sort, in order to maintain that. If you just use like array.sort, the standard sorting method for JavaScript arrays, then it's gonna increase the time complexity to linear no matter what. But this is a good way to quickly sort through a sorted array and find an index. And that's all we got for today. Thanks for tuning in. See you next time.